Hello, this is Mr. Stansbury. I'm going to take you through the notes on direct variation. Okay, at the end of this, you should be able to say, I can show that two variables can be directly proportional, and I can find a formula connecting the variables. Okay, so first things first, direct variation. Two variables are directly proportional, or another way of saying that is very directly, if multiplying one of the variables by a number results in the other one being multiplied by that same number. Okay, I know that sounds kind of weird. So what we'll do is we'll kind of talk through all this thing here, and then I'll give you an example which will make that make this a little bit more clear. Okay, if variables x and y are directly proportional, we write y and this little fish looking thing and an x, and this reads y is directly proportional to x. Okay, or y varies directly as x. You'll usually hear this one more often. Okay, y varies directly as x. If y varies directly as x, then y equals k times x, where k is just some constant, and we call that the proportionality constant. And then when y is graphed against x, it is a linear graph that passes through the origin. It's very important that it has to pass through the origin, otherwise it is not directly proportional, or y does not vary directly as x. Okay, and it has a slope of k. All right, so hopefully at least these made a little bit more sense. This is going to make more sense once we take a look at an example here. Okay, so for the table of values, plot the graph of y against x. So basically they're just saying graph these points. Okay, so when x is 2, y is 5, x is 3, y is 7.5. We're kind of running out of room here, aren't we? When y is 4, x is 10, and then at 5, we're way up here at 12.5. Let's see, probably about there. And then 6 is way up yonder, way up around there or so. Okay? So, what we got to do is we got to figure out now, so we did this, we got to determine whether y is directly proportional to x. Okay? So if y is directly proportional to x, then this is going to make us a nice straight line, and it has to pass through the origin, otherwise there's no dice. So let's just do this. Let's just start right here at the origin, draw ourselves a line, and look, it does happen to go through all those points. Okay, so determine whether y is directly proportional to x. If it is, find the proportionality constant. So first off, yes it is. And the big reason why we can tell is it makes a nice straight line that passes through 0. Okay, and then now to find the proportionality constant. Okay, basically what we're getting at here, when this goes up by 1, this goes up by what? Basically, that's going to be our proportionality constant. So as this goes up by 1, okay, because we're adding 1 each time, plus 1, so forth and so on, what happens here? This goes up by 2.5, and again by 2.5. Okay, so we take our 2.5, as this goes up by 1, this goes up by 2.5. So we can kind of look at it really as a slope. So 2.5 over 1 is going to give us 2.5 is going to be our proportionality constant. Okay. Another way to look at this is, let's say if we didn't have these numbers in here, we just went from 2 to 4 to 6. So as we went up by 2 on the x's, we went up by 5 on the y's. So 5 over 2 gives us 2.5 that way as well. And it should work, like every one of these has to be the exact same, right? So like, how about this, for example? Let's say if we had 2, 3, 4, but we didn't have 5 or 6. I mean, sorry, just 5. This goes up by 2.5. This goes up by 2.5, and then you're saying, it's like, wait, this goes up by 5. Well, this goes up by 1. This goes up by 1, and this goes up by 2. So again, if we take the 5 over 2, we're still adding 2.5 for every one of the x's. We're adding 2.5 to the y's. Okay, so that would be your proportionality constant. Okay, so let's kind of go back Now that we have that, let's go back and take a quick peek at this again. Two variables are directly proportional or very directly if multiplying one of the variables by a number results in the other one being multiplied by the same number. So we basically we multiply on this one here. We are multiplying this number. Really, we're multiplying this by our proportionality constant. We're multiplying by 2.5. So 2 times 2.5 gives us 5. 3 times 2.5 gives us 7.5. 4 times 2.5 gives us 10. So forth and so on. Okay? Okay. These other ones hopefully still make some good sense. If variables x and y are directly proportional, we write y varies directly as x, or y is directly proportional to x. We found the proportionality constant, okay, and that we can write as y equals k times x. So really back on this problem here, we could write it as y equals our proportionality constant k times x. So in this case, it's going to be y equals 2.5x. Okay, so like say, for example here, 10 happens to equal 2.5 times 4, because 4 is our x and 10 is our y, right? So 10 equals 10. Okay, so see how that works? Okay, and then when y is graphed against x, a linear graph, it's a linear graph that passes through the origin with slope of k. So again, looking back at this here, it passes through the origin, 0, 0. It's super important. It has to pass through that to be directly proportionate. And the slope here is 2.5. Look, as we go over 1, we go up 2.5. As we go over 2, we go up another 2.5, up to 5. So all of these are 2.5. The slope of the line here is 2.5. Okay? All right. Last thing, we'll take a look at an example here. But before we do that, let's do a quick comedy break. Okay. All right. Example 2. Suppose t varies directly with v and t equals 14 when v equals 9. Find v when t equals 40. Okay, so let's just set this up really quick. Okay, so this first one is going to be our y. Second one is going to be our x. Okay, so if we kind of set this up really quick here, v and t, t like so. We've got t equals 14 when v equals 9. And then when they want to know, find v when t equals 40. Okay? Okay, so basically we got to find something to multiply 14 by to get to 40. So we have 14 times some number equals 40, right? So divide both sides by 14. And that number that we got to multiply is 40 over 14, which is this number over that number. Okay, so since it's directly proportional, we have to also multiply this. So we're taking this, multiplying it by 40 over 14. We also multiply this by 40. 40 over 14, and that's what this number here is going to be. Okay. Okay, so we take 9 times 40. And divide it by 14. Okay, and we end up getting 25.7 for that one there. Okay. All right, I'm going to leave this at that. There is a different way to do this, but I have a feeling if I show you a couple different ways, some people might get the two ways confused. So if you really don't like this way, you can ask, and I'll be happy to show you a different way. But let's try to see if we can make this one work. So again, to get from this number to that number, we said, oh, we have to multiply 14 by some number to get to 40. So it's really just going to be this number divided by that number, right? Because if we take 14 times 40 over 14. Look, the 14's cancel and we're just left with 40. That's why we can always do that. And then you just take this number here and multiply it by this 9 up here. 9 times 40 over 14 is 25.7. Okay? All right. If you have any further questions, please feel free to ask in class. Thanks.